Alright, time for another DraftPhysics.com, debatephysics.com also, but again the debate is in a hideous, monstrositous, disgusting form of distortion and perversion, just lies and deception, constant scheming and manipulation by people who are overtly and almost proud to be dishonest. And as a group, that's all they are. They don't regulate their own conduct at all. Every one of these assholes has to take responsibility for the fact that they have let this moron, this Ian Gosling, make 10 straight videos that are just a complete lie and waste of time. Not one argument that isn't a straw man, not one argument connected to anything actually stated. Just lie after lie. And now he's posting a video pretending he's doing his clay experiment that he hid from everybody, when he's clearly going to distort it and change it and manipulate it for the purpose of forcing the results to come out his way. I mean, it's so obvious. That's all he's doing, is finding some gimmick, some method to cheat the fucking truth. We have his honest testimony in a previous video where he said he did the experiment multiple times. He couldn't get it to come out any other way. We need to have an explanation because of the way it came out. And then he does this lying. And this is so obvious. This is as obvious as, karate school, where you see somebody break a piece of wood, using a minimal amount of energy because they apply the energy quickly. Tearing clay is a lot different than compressing clay. I mean, again, even a little kid can figure it out. You can figure out what the manipulation is. I mean, this isn't anywhere near as clever as denting clay with round objects, but it's the same damn thing. It's quote mining the evidence. I just made a video making that direct accusation. That's all they're goddamn doing, is cherry picking evidence. Do a bunch of experiments in different ways and try to force it to come out your way. This is just propaganda, and fuck this. Alright, so I'll do a little bit of a real video first, and then we'll play this crap. But again, it's just obvious. He's just changed the experiment, pretending he's doing the same experiment when it's a completely different experiment. It's just so fucking dishonest. Alright. See if it freezes when I close this. Not. Having a little trouble with OBS lately. Alright, so the gravity one. Okay, so we went over and over this. I mean, little kids can figure out this simple thin ice subject. That if you have some thin ice, that if you want to cross the thin ice faster, you won't fall through. And why? Because the simple truth is, per foot you weigh less. So there's lots of ways of understanding the fact that gravity is a time-dependent force, which means you don't instantly weigh your weight. Your weight is a consequence of a motion, a pressure you're putting into the earth. And even that, I think a little kid could figure out when you say, hey, what do you feel? You feel the earth constantly pushing back, right? You feel the pressure. It's not a one-time event, okay? You sitting in your chair is a repeated event. Something's happening and it keeps happening. It's not it happens and it's over. No, it continues to happen. You push into the earth pushes back. It's just just so obvious. Again, like I said, little tiny kids could understand it. Even kids fooled by Santa Claus could understand it. Alright, well, he is sort of that kind of fool. I think he is a god bother of some sort. So anyway, just too stupid. So I was thinking of another analogy. It's like I could use the sewing machine analogy. Needle goes in at a rate, okay, and makes a stitch. And certainly you could understand that if I pull the fabric, okay, away at a faster rate, that the stitches get longer and longer and longer between them. And if I make it go slow, that the stitches will be very close together. And that gravity's doing the same thing. It's a constant force. And the simple truth is you can only collect so much of it. And how much you're going to collect is going to be completely dependent on how many times you hung around to collect it. You have a certain surface area you're collecting with. and how much time did you spend in the area, all right, being affected by the force. How much force was in the area, the space, and how much time did you spend in that space. So another way to look at gravity, I thought, that a more technical, more elementally understanding it, it's kind of like the light bulb argument. Okay, the sun will shine, and you could have an object, let's say it was that the sun was a pushing force, and you have an object and it's getting hit by photons and it starts to move. Well, what's it really done? Well, it's absorbed photons going in all kinds of directions. It's absorbed some going this way, some going this way, and some going this way, and it's converted all of that motion into the only vector that matters to it, which is the motion this way. It can only move in one direction at a time, so it has to force all the collective motions to add up to one motion. And so what it's really doing, right, is it's absorbed photons that never hit this surface. All these photons that hit this object gives it motion. All of those photons never hit the surface. They got shadowed. Okay, so it casts a pretty big shadow because there's photons getting blocked going this way, and there's photons getting blocked going that way, and there's photons being blocked going straight down. And so what you really has happened is that the energy's still here. So all of that light is just waiting to hit the surface, frankly. It's been stored, it's in this object, and now when the object hits the ground, it's just restoring all of those little impacts. It's just going to give back all the photons it collected. It casts a shadow as it absorbed acceleration. So when you're free falling, you're collecting what would have been pressure that would have hit the earth. And the pressure didn't hit the earth because you were in the way. You absorbed it in all these different directions, in the direction of your motion. And the fact is that that pressure didn't hit the earth, and the earth, was a little more relaxed because of that. And then you were bringing the energy with you. When you finally hit the surface, you take all of this would have been pressure and you apply it to one space and make a little deeper hole because of it. So you relaxed the pressure over here and over here, and you just did the same amount of pressure here in one spot. So it's almost like a bullet argument or some other argument where you can take the energy and you can compress it into a smaller space, okay, and it'll behave or do something more dramatic, something you won't, it's seeing versus not seeing. And the same thing, you could argue about pressure on a surface, and you can break a piece of glass, okay, with a little tiny impact, as long as the impact's in a tiny area. And then you can apply a lot of pressure over a large area and get nothing, see nothing. There'll be no evidence of the pressure. So you're really just giving back. All force has to be accounted for. So if you're getting energy from something, if you're moving, something else isn't. And I think that's a real interesting fact. Okay, so if you're getting pushed somewhere in the universe, something else in the universe isn't getting pushed because you are. The push is all around us. It's in the universe, and there's only a certain amount of it. So if you're using some, it's not someplace else. And if you weren't using it, it would be someplace else. So I think that is a very interesting fact. Ignored by these cement-headed, belligerently stupid, lying sacks of the smelliest, dirtiest, cruddiest human garbage you can imagine. I mean, this is human garbage. They lie about who Newton was, what Newton believed. They slander wherever possible to defend a faith. And that's all they have, is a faith. They don't have any reasoning. They don't have any logic. It's been demonstrated that the guy who started this, whose name they never even use, right? So the guy who invents the theory, the first guy who thought of it, they couldn't care less if he's dissed for all of history. Why? Why doesn't he get to put his name on your brilliant theory? Oh, that's right, because his logic and his reasoning sucked. That's why. Okay, and then the Deschartelet, I mean, her name sort of fits. I mean, she had a fancy pants name too, lots of money. And the whole pretense of the denting clay bullshit, another canard, charade experiment. Just complete bullshit. if somebody really analyzes and looks at it. It's got no logic to defend it. And yet these people just keep shoving this shit in front of the human brain and saying, look, you must believe because we have faith. It's our sacred God religion. It's our totem pole. And we will whap you with it. Okay, we will smite and destroy and in every way try to discredit and cheat. Okay, anyone who disagrees with us. Puro. What what scum you people are. God damn it. Alright, so this is, I just have to be a prohibition. He's had 10 videos where he just keeps lying, straw manning, absolute crap, just completely wasting my goddamn time, so I'm just not going to watch his videos. It's clearly just a realm for lies and deception, nothing else. Alright, so I have repeatedly pointed out that he's shown no credibility in the fact that he didn't videotape and show his original clay experiment. So let's understand the context again. He posted a video saying proof of kinetic energy, and he did a clay compression video, and he got very good results, but he had made a huge giant measurement error. Okay, and the fact was that's the only reason why he got the results is because he made a huge giant mistake. So he corrects the mistake and he gets results perfectly consistent with my predictions and assertions, and he doesn't videotape the experiment, doesn't show the experiment, and just mentions, oh, we got to fix this because it came out the wrong way. I mean, it's so obvious that they're just trying to force the evidence to match their theory. I mean, that's the clear, obvious accusation. And then they claim that I'm doing something inappropriate by finding flaws in their experiments when they won't do it for their own. So the one that comes out my way, instead of explaining why it came out the wrong way, instead of showing it and then explaining why it was a bad experiment and why it was bad theory and why he never should have titled the first video proof, because it really wasn't a proof. The experiment's not going to show what he thinks it's showing. I mean, all of that, instead of retracting all of that and fixing it and showing some integrity, no, nothing. He just keeps contriving experiments and pretending they're in some way honest, like he doesn't know the real truth, like he didn't really see it by doing the other experiments and finding out that it doesn't work his way, which is kind of obvious that that's exactly what's happening. So instead of doing that experiment, he's pretending he did it. Okay, so he's gone back to crushing clay experiments, but he's going to do it in some modified way to force the results to come out his way. And that's all this will be a demonstration of. I mean, clear bullshit. Alright. Like I said, so dishonest. Alright, so this pipe is much thicker than the original one. He doesn't have any plate here for crushing the clay. What he's going to do apparently is just tear clay off the sides of the clay pedestal. So again, if I say the word move, or I say the word tear, I say the way crumple versus tear, I mean, people can understand that yes, these things happen based on different applications of energy. That people can actually tear phone books if you do it the right way. Okay, a phone book that could hold an elephant. I could balance an elephant on the phone book and it won't tear. But if I tear it just the right way, okay, I can use a minimal, tiny amount of energy and get the result. So we already know that those mechanics are based on the application of force, not the mere existence of force. You want to make this as simple as possible and have an experiment that doesn't have any bias, that doesn't say fast things can make it happen, slow things can't make it happen. Those kinds of experiments are exactly what you want to avoid.
Go back to these plasticine experiments, but we're going to do some more plasticine bashing. I've got a thicker plastic tube now that's going to be the central guide.
Right, which is just totally useless.
Going up.
Just more friction, right? So the only thing you're trying to do is stop it from wobbling or going really poor, really crooked. So you want a minimum amount of manipulation, not a maximum amount. So obviously the more surface area, the more friction you're creating. Not a good idea.
4 times the height mark, and the 1 times his height. So I'll make sure I put the weights on top of the line, of course. Although actually I think that disfavours the 4 height drop.
Well, that's because you're stupid.
I think it should be done from the centre of mass and worked out.
It's going to hit on a surface. The simple truth is it doesn't matter where the center of mass is, because you have a surface that all the energy is going to be passed through. So it really just matters where is the surface. The center of mass doesn't matter.
Because there's actually...
It's like him not understanding how a scale works. You know, that a scale has a platform, right? But all of the energy goes through this little thing here. That's where all the energy goes. So the platform is just a funnel. You can't change how much is going to go into this little stem by putting the weight here, or putting the weight here, putting it here, or moving it around. You can't change how much is going through the funnel. But he's too stupid to understand that kind of simple concept. That's why it's just useless to have a physics conversation with this, 6-year-old.
Should be the centre of mass.
This intellectual midget.
The bottom weight, and then 4 times the centre of mass, which would be a little bit higher than the line at the top, which is just 4 times that one distance.
So after all this time to think about it and do all this stuff, he still hasn't figured out that that none of that shit could matter. You're measuring where a surface impacts, and all of the energy has to go through that surface. So it might as well be the surface is the center of mass, because it will be the center of the action.
Anyway, what I'm going to do is now I can pause it, I can do the re-rolling and all the boring stuff, cut that out hopefully. I propose to do at least, I'm just going to do it in one take, and I'm hoping what's going to happen is what happened before.
So he's just going to hope, and so we're supposed to think, oh yeah, I didn't engineer anything, I didn't change anything. So again, he already posted the previous video. He spent a whole day trying to get the experiment to come out his way, and he couldn't. And then he posted a video kind of distressed. Like, come on guys, he said these words, come on guys, we have to figure out what went wrong. Yeah. And now he's going to speculate that somehow the experiment's not going to come out the same way. Oh, that's right, because you are going to do it differently. Oh, okay, got it.
As I explained, that the plasticine starts to cleave internally.
Which wouldn't have anything to do with you getting identical results. That would be an excuse if your results were erratic. They came out very different. It doesn't explain perfectly consistent results.
And starts to fail and gives way and collapses on any given.
Again, would not explain why your theory says there's twice the energy and it shows absolutely the same exact amount of energy. So it wouldn't explain that. It's not, if you keep getting exactly the same amount of compression, you just can't blame it crumbled.
Height drop. But I'm going to start off doing a 1 height and then a 4 height. Or what should we call it? 1 velocity and 2 velocity.
Yeah, duh. That's the whole point of the experiment, and you're supposed to use the half mass at 4 times the height. Yes.
With half the mass on the 2 velocity,
there
of course.
You go. Yes.
I'm going to do a couple on each.
Oh, whatever. I'm just going to speed this up. This is just bullshit. I mean, that's all this. This is just, why is he bothering with any of this crap? Yeah, why? What's the point of it, the purpose of it?
It should be good for about 2 or 3 on each. And then I'm going to just continue perhaps with the bottom drop. And I'm going to keep going until it starts to cleave. So to show you what happens. I would like it to stop doing that.
Yeah, exactly. Why couldn't you just show us that in the first video then? If your results are becoming erratic and inconsistent, then why wouldn't you say, oh, obviously this experiment didn't work because look how inconsistent my results are.
because that's what happened before. Right, anyway, we'll start. I've got this vernier gauge set up with these platform bits to measure the clay. I won't be able to show you in front of the camera too much because the light is no good. But that's, I'm going to, this 105.
So it's obviously a little thinner than his original setup. So he's made the rod thicker and he's made the clay thinner.
Mil is about the length I'm going to get before each drop. About 105 mil.
So that basically obligates, because it's essentially a cylinder, okay, that the distribution of the clay is the same.
It's going to be give or take a few millimeters. The weights are 2.5 pounds weights. So individually it's 2.5 pounds, and together as they are there, that's 5 pounds. It's got a bit of tape on around the edge with some washers so that they're exactly, one's double the weight of the other.
So in the original, he had metal plate on there that kind of ensured a nice even impact. But let's see what he's doing, you know.
So I'm going to start off with the two mass and one velocity.
All right, so he's got nothing. He's basically going to force the clay to go up inside the hole. Right? Because there's no flat plate anywhere here. So he's got a tiny little edge of the clay he's hitting because of the bigger round thing he's got in the way in the middle. So it's essentially guaranteeing he's going to get a very uneven compression.
3, 2, 1, go. What's that? Call that 80 mil. Yes. I'm going to re-roll it.
Yeah, I don't know why that's so difficult to show us, but you know, whatever. So apparently, the clay doesn't it doesn't separate so easily that because of the bigger round, it still compresses fairly well. But you know, I still have my doubts that he shouldn't fix that. I mean, it's not that difficult to just put a round thing on top of the clay, you know, so the weights hit the flat surface and evenly push down on the clay.
Another one with the 2 mass.
The good news is these are fairly easy to replicate experiments. I mean, you come up with some better way to do it, but yeah, not that tough. I mean, he's got a caliper. He's not using it as a caliper, which is kind of strange. He's just using it as a ruler.
75.
So 80 and 75. I mean, not great. That's like whatever, 7% error. No quick release or any of that, of course.
75. Three, two, one. $75. Now I'm going to try the 2 velocity on this.
That's good, good. Yes, thank you.
3, 2, 1, go. What's that? 65.
So, miraculously, right? For the last time he did the experiment, they came out the same, 75, 75, right? So, miraculously, okay, this time the results are coming out different. So he spent a whole day and he couldn't get the results to come out different. But today he can. What a surprise.
Should be able to get a couple more.
So just proving that all you have to do is manipulate an experiment a little way. Change the variables a little this way, swing them a little that way, and you can get whatever fucking results you want. Just showing how corrupt, science can be in the hands of lying, God-bothering faith and nutters. Alright, his theory is it has twice the energy, so obviously it's not showing twice the compression, but regardless, it's not showing the same compression.
3, 2, 1, go. $65. Do one more for that.
And we also never saw the measurements, right? Did he really get them right again? Who knows?
Because according to your theory, Gary, they should measure the same, shouldn't they?
Yeah, according to your own experiment that you spent a whole day on. What, should I play your video where you were pointing out how no matter what I did, it came out the same every time? Should I play the fucking video? And now miraculously you got it so it doesn't come out the same every time. Miraculously. The miracle of science propaganda. If it doesn't fit, force it to fit.
3, 2, 1, go. $65 again, guys.
It certainly does look like more than twice the velocity, but who knows?
Right, I'll go back to the 2 mass 1 distance. This could be a long bloody video. 3, 2, 1, go.
So obviously he has very little room for error in the release of the heavy mass. It's going to move much smaller distance. Any little, movement of his hand without really releasing the weight, and it's also a heavier weight. It weighs twice as much. Obviously a little bit harder to let go of. So who knows? Maybe in the previous experiment, because it was a little lower, he dropped the weights this way, instead of doing it this way from above. But who knows? But it's obvious contrivance, right? I mean, this is just so obvious. So the first time he did it, he couldn't get the results to come out different, and now he can. It's just a miracle. Miracle of science.
74. I'll keep going. See what happens.
Yeah, see what happens. I think we know he already saw what happens before he played out this theater.
Let's get down towards 71 now.
Yeah, why don't you alternate? Do it from above, then do it low, then do it high, then do it low, then do it high, then do it low, and then any softening of the clay based on how warm it's getting won't have any effect. But again, this requires him to think a little bit, and he couldn't be bothered. Now one-handed this time.
70. 70, that is.
Yeah, so you got 80, and then you got 75.
You won't see it.
A little too late for that.
It's starting to deform. We'll carry on.
Yeah, we'll carry on.
Three, two, one, go.
So his argument is that Play-Doh doesn't work. You know, somehow Play-Doh isn't Play-Doh. You can only use it once and then you have to throw it out. Yeah, I don't think so.
It's about 70 again.
So 5 75s, 2 70s, and 180. I think that can all be blamed on the fact that he doesn't have a quick
It's
release,
about 72 now.
a consistent dropping method.
It might go up and down, see?
So none of this, he didn't notice any of these problems when he did the experiment for a whole day trying to get the results, and he couldn't get it to come out any other way than consistent with what I argued, that they would both be the same compression. And now, oh yeah, now there's all kinds of variation. Yeah.
Three, two, one, go. 70. I'm expecting it, as we continue, to start to collapse. But how long I'll have to continue doing this before I witness the failure. 3, 2, 1.
So again, what would, even if this were true, okay, that you had to give the Play-Doh a rest, okay, you could do it 10 times and then you had to rest it. Why would that mean the results are useless?
Go. Might not get any worse than that. It's a consistent 70 at the moment. Let's try one mass again.
Shall we predict 60?
3, 2, 1, go. 72.
Oh, 72 went up. Went from 65 to 72.
And that should have been 65, if I remember
Yeah.
in the first runs we had. 3, 2, 1, go.
So somehow,
Yeah, that's going down to 70.
so the heavy mass went from 80 to 70, and the lighter mass went from 65 to 70. Okay.
Or even just below there, see? About 70, just below. Back to the 2 mass.
I mean, just for the sake of the argument. So Despar argues that his experiments are just so far from my predictions that there's no possible way he could be making an error that could account for that. So this experiment is essentially showing that it's nowhere near twice the compression. Okay, I mean, just nowhere near it. And he also is, the argument could be made that he's measuring the compression the wrong way. You're supposed to measure how much clay is missing, not how much clay is compressed, right? So he might not be measuring the right thing. I think he's trying to measure the right thing. So I think that's why he has the calipers all the way extended, is he's measuring how much clay is missing. So, but regardless, no matter which way you talk about it, he's obviously way off of the twice number he's looking for. Okay, so the one mass by kinetic energy theory is supposed to have twice the energy. It really should be displacing, removing twice as much clay. The half mass at twice the velocity.
Go. Yeah, 70. I'm starting to see what happened before. That the two different drops were getting the same result with the clay. And if you remember, when I started off...
So twice the energy is somehow the clay isn't recognizing twice the energy. So you could simply fix that by just dropping the 2 mass from 4 times the height and see if it can register twice the compression. Because obviously if it can, then there isn't really a problem. Their theory is it'd be 4 times the compression, right? So that's their problem. But yes, it's only going to be twice the weight, not 4 times the weight.
You can't see this cleaving inside of this clay, but it's splitting. And it fails. It's not consistent.
So again, he says, okay, that somehow the movement of the clay is fundamentally destroyed because it does start to get skins on it, okay, and it's not perfectly all connected to each other. And it is true. I have this little better stuff that's sculpting clay, but the trick is he does it too. It cleaves, it breaks. But it's not the end of the world. I mean, you can make an argument that that's not going to make that big a difference. And if you're going to make the argument that it does, you're going to have to prove that it does in some way by showing a result that is completely outside of the bounds of a reasonable demonstration of energy by, like, say, neither theory.
When we started off, we were getting 75.
No, you start off with 80. Okay, so let's just understand. You start off with 80. I'm still trying to understand what thing he's measuring, right? Because was the 80 more compression? So that was like a lot of compression, the 80. I mean, the higher the number, the more compression, I think, is the way he's measuring it. He didn't even show us that, frankly, which is sort of annoying. So that first 80 demonstrated more compression.
Well, then it went down to 73, didn't it? 72. And the higher mass was getting 65. Weren't the same, there was a difference. But now, whichever one we do, we just get a consistent 70.
Yes, which could be an argument that the clay is now evenly, the temperature of the clay has now gotten even because you have manipulated over and over again. So now it's gotten, in some ways, more consistent.
That plasticine is not consistent.
Well, says you. Okay. So that's his theory. So he did the experiment, frankly. I don't like that he changed the technique a bit, but whatever. And the fact is these results are completely inconsistent with his theory, so now he has to live with it. And he has to explain, well, he's going to say the clay always reads the same number for whatever no matter what he drops, an elephant, a truck, a mouse, it always compresses the same amount because it's magic, whatever, deforming clay, and it doesn't matter what he drops on it, it always compresses the same amount. I mean, that's kind of his argument, right? What other argument he's making? So that's his big excuse for why the experiment is a failure and shouldn't be taken seriously. I'd say it's pretty lame, but whatever.
I don't think it's any good for the experiment at all.
Yeah, see, because it didn't come out his way, so it's no good an experiment. Now, see, I don't say that. I don't, usually I say, look, you can fix the experiment, just fix a couple of these details, and you can make a better experiment. And the detail I'd fix first on this experiment is I'd definitely put a $50 on top of the clay or something a little bit bigger, a washer of decent size, and just to ensure, okay, that you are compressing the clay kind of evenly and that you don't have any clay going the wrong way. But whatever. Play.
Well, I hope you appreciate that. That's my present to you.
Yeah, no, I don't really appreciate it just because it isn't, exactly the same, and you don't accepting the context of your previous experiments, which didn't show this problem. You didn't describe this problem, you didn't show this problem, you didn't say there was such a problem. That came up later, okay, So in the video you made the day after you couldn't get the experiment to work your way, you didn't have any of these explanations. You hadn't noticed this inconsistency then.
I hope that's the end of all this constant going on about I've deceived and I've hidden and I've cheated.
Well, not really, because obviously that's what you're intending to do. So, it's always the game you've been playing. So, I mean, the fact that, yes, okay, you have shown the experiment in essence, I'll accept, yes, okay. These results are not favorable to your argument at all. That's true. And your explanation is, though, it's magic Play-Doh, and it always compresses the same amount no matter what I drop on it. I'd say that's pretty lame.
I won't show. I've done it honestly and openly, and that's what it is.
Okay, it is what it is, exactly. So, and what it is pretty conclusive evidence in the sense it's 90% my way and 10% your way. Alright, so dispar, how do you explain it, dispar? It's pretty much 90% my way, 10% your way. You really think you can find that 80% that's missing for your side? Blah, 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 blah. Yeah. So, we'll see. But again, I think there's a certain logic to finding these experiments. I've stated in the previous video, if this was easy, they wouldn't have named the joule after joule. It's not that easy, okay? It's a little bit difficult to actually extract energy from objects without leakage, without losing energy to outside your measuring container. It's not like just sticking a ruler up against something. It is more complicated. And all of that crap has to be taken into account, and all these little variables and all this bullshit. And but clearly you're showing none of that. His willingness to disqualify the experiment. You saw how easy it was for him to disqualify this experiment. Why doesn't he have the same ease in disqualifying the other experiments that also show some variation or fallibility? Oh, it's right, because the results are 90% in his favor. So the 10% doesn't mean anything. Yeah. That's the hypocrisy. Alright, so yes, at least now we have a clean record. And so now they can explain why this experiment is garbage and useless and deceptive, and why, say for example, the Chartelet experiment, it has integrity, or why the dispar experiments are perfect. So I don't know. Fall was held. This is a good result, Ian. What is the point? Okay. Is there any point in the conversation? I mean, he's going to claim the failure is victory. Okay. Whatever. I mean, there's no way to make any sense out of that. Look, he's claiming 1.4 again. One mass is twice the energy, so you'll be looking at 30 times 1.4 compression. 30 times 1.4 equals 42 millimeters. So where did he get any of these numbers? 62 millimeters. You just can't make any sense out of that, can you? No, you can't make any sense out of that. So he's declaring victory. Let's see what Ian says to this. 25 times. Where does the 25 number come in? Was there a 25 somewhere? What's that, John? Yes, he had to ask, what is that? Where was 25? Where was this 30? Where was the 42? Where was even the 62? I mean, none of these numbers are even in the experiment. Oh, it's just pricelessly stupid. Alright, anyway. Fuck. Just goes on and on. What nonsense. Yeah, there's nothing. I mean, there's nothing to say. I mean, this debate is garbage and crap. I mean, the facts just don't matter to these people. So till the next time and such, so forth and whatnot.